right, I think we're going to get started. So welcome everyone to our session this afternoon. It's funny how we have lunch on the last day of the conference, and then for some reason the attendance sort of dips, to say the least. But the good news or bad news is I was looking at some of the other rooms, and I think it's about the same. So anyhow, I'm Marc Cohn, and I am with ClearPath Networks. And I also am on the board of OpenDaylight. I actually represent the silver members, including some of you. And today I'm going to be talking about how OpenDaylight enables virtualized CPE, which is a use case that's getting a great deal of attention from the telecommunication community as well as the cable operators as well. And we'll talk about what it is and also about how it's evolving and what the role of software-defined networking is. Before I get into my presentation, I did want to say a few things about ClearPath Networks. It's an employer. Actually, it's a relatively new employer. I moved there just a couple of months ago, and I'm leading the marketing operations. ClearPath is a company that's really attempting to alter the economics for innovative, cost-effective, and personalized service delivery. And we'll see how virtualized CPE plays into that. Our heritage is really, the company's been around for about 12 years, and we've been a pioneer in cloud-managed networking, and it's really an evolution over the past number of years of how the company has really moved from being in the CPE business and then innovating into helping enabling the cost reduction, not to mention the agility for delivering services at the access, and then also being now playing in the space in a broader context where open source becomes much more important as well. We've actually deployed our platform in some very large operators, and we have a long heritage in the CPE business, and we also have been working in the cloud and cloud managed services business, as I mentioned. ClearPath, for a very small company, has a very prominent role in a number of organizations, including the ones shown here. OpenDaylight, of course, OPNFV at the board level and at the TSC level, ETSI NFV ISG, as well as the Open Networking Foundation. And our involvement in the community has been important for two reasons. One is, of course, we have been able to get a lot out of understanding and engaging with the community to understand requirements, to help refine how our product is both developed and delivered. And then at the same time, we want to contribute back into the community. That's one of the reasons why yesterday we announced that we joined OpenDaylight, and you might have seen that announcement along with as one of the newest silver members with AT&T and Nokia. So what I want to talk about first is the macro trends. What's the big picture that's driving operators to think about new services delivery? And what are some of the challenges and the problems that they want to address? Then I want to define what is virtualized CPE. It's a term and a concept that's actually being it's being kicked around in many different circles. However, we have a specific meaning for what virtualized CPE is and is not. I want to address target use cases, and then talk about OpenDaylight and rather SDN in OpenDaylight and virtualized CPE, and I certainly want to allow time for questions. So some of the big picture trends is that in the at least the telecommunications and even the cable market, it's actually some very similar trends. End user expectations are definitely shifting. I mean, everyone expects to be able to get all their data on any device, anywhere, anytime, and this is having dramatic implications in how network services are being delivered. And all you have to do is go to the hyperscale operators, the Googles, Facebooks, and Microsofts, and see how they've changed the way we actually look at service delivery. And it's certainly changing the approach for many of the world's largest telecommunications operators and cable operators, because they're now being forced and thrust into the competitive landscape that's really quite different than what they've had to deal with over the last 10 years. And 10 years may sound like a long time. It certainly is in internet time, but in telecommunications, it's really not that long of a time, as we've been hearing earlier in the week. And with that competitive change, it's forcing technology to evolve much more rapidly than it would have otherwise. I think Christine Heckert from Brocade in her, actually she shared a talk. She's a CMO from Brocade, by the way. She shared a talk at the Open Networking Summit about how revolutions happen every 20 years. And I think what we've seen with SDN and NFV, even in the last 5 years, it's been a dramatic shift, and it's really changing not only the way the technology will be delivered, but also just how we're looking at it and even considering it. And it's having widespread implications across the industry. And of course, with SDN and NFV changing everything, we have to really rethink and relook at not just technology, but also the business models, the commercial models, and then most importantly, the impact it's having on the organizations up and down the value chain, whether you're a network operator, you're a system integrator, whether you're a manufacturer, a software company, or even the end user. It is really beginning to have a dramatic implication. And if you have any doubt about whether operators are committed, this is a chart that our good friend Michael Howard from Infinetics Research did. He surveyed over telecommunication operators representing over half the world's CapEx. And the question was, will you deploy SDN and NFV? And the numbers are quite staggering. 97% of those operators, and these are the largest operators, and this is representing, hundreds of millions of dollars of CapEx, or billions of dollars of CapEx spend, are planning to deploy SDN, and almost the same amount, 93%, are planning to deploy network functions virtualization. And with these kind of numbers, and this is data from 2014, I suspect if we did that survey today, we'd even see slightly higher numbers, because there isn't an operator who really isn't thinking about SDN and NFV in everything that they do. So what are some of the problems? Well, I tried to map it out into 3 distinct problems: the revenue problem, the cost problem, which is related, and the agility problem. The revenue problem is clearly the fact that even though there is additional value with higher speed connections and some value-added services, the ARPUs, the average revenue per user, has actually been pretty flat. You've seen some ratcheting up in some mobile services in certain geographies, but for the most part, considering the demands on the infrastructure, the revenue situation has been quite troubling for operators for a number of years. The cost problem is that the capacity increase, as we're seeing mobile data just take over and consume not only the mobile infrastructure, which I think is somewhat intuitive as we watch all of our teens go to YouTube as the second largest search engine in the world, or in North America. I shouldn't say the world, because I think if we go to China, we'll see even bigger numbers. But also, even if we look at what's happening with the over-the-tops, especially Netflix, who gets a lot of attention, which is consuming a huge amount of proportion of bandwidth in the network. And the only way that operators right now can be able to deal with flatter ARPUs and skyrocketing demand is innovation. And that innovation comes in a number of different areas. Certainly, we can look at raw capacity. 100 gig take-up rates for the carrier network has been dramatic. It just bypassed 40 gigs for those of you looking at the lower layers. But it's also about being able to apply the cloud metrics and perspective at the upper layers, which is we're not just looking at how can we deliver things the way we used to, but we're looking at what's the service density per kilowatt or the service density per cubic meter. We're looking at the way in which the data center is now evaluating network capacity. And the agility problem is also a major problem for operators to deal with. And this has more to do with how operators are able to cope with these changing user expectations that everything is going to be available yesterday. And it's not just in terms of accessing data. We used to look at metrics, things like what's the response time of applications or even the web in terms of presenting a page, because there were lots of research done several years ago that indicated that, if we don't present it within, some number of seconds, and I think that number has probably gone down over time, that user will bounce. Now we're looking at, can we deploy new services? Can we tailor those new services? Can we change those services? Can we get dynamic capabilities that didn't even exist? Those are also part of the agility problem. So operators today are facing, a tremendous amount of pressures that they didn't face in the past, and it's primarily because of all these factors that are actually contributing to pressure on the industry to be able to drive new models, new innovations, and new technologies that are going to support their networks moving forward. So let's enter virtual CPE. This is one of those technologies that's actually going to help. What is virtual CPE? The idea is to be able to virtualize capabilities that were traditionally embedded into hardware and being able to deploy those in a flexible manner. It's a very generic definition, but I'm going to elaborate on most of these points. And when we look at virtualized CPE, the idea, and we'll talk about the evolution in a minute, but the idea is not necessarily to just virtualize what's there today and then try to force fit it into an operational model that is familiar. It's to really adapt the overall ability to be able to deliver new services and be able to do it in a very efficient manner to open the door to new capabilities and innovations, and from many operators' perspective, differentiation for value's sake. Now, how is this going to happen? Well, first, we're going to leverage network functions virtualization and cloud technologies. For those of you who aren't in the carrier space, NFV, you probably heard of it. What it really means at a fundamental level is pretty much the same as virtualized CPE, but it actually originated from the infrastructure aspects of the network. In other words, the operators who got NFV off the ground were thinking they have thousands, if not tens of thousands of hardware appliances in the network. We have to be able to do something with them because the cost to patch them and upgrade them and maintain them, not to mention the hidden cost of the fact that many of the embedded devices are running at a very low utilization, and that capacity is stranded forever. You can't really recapture that stranded compute and storage capacity. And what the idea and the vision was to be able to create a virtualized infrastructure that was tailored around telecommunication operator needs, and actually in cable operator needs as well, and then be able to enable a much faster delivery model for those capabilities, not to mention the cost reductions both on the OpEx side primarily and then even on the CapEx side through the use of x86 servers, through the use of open source technologies that, of course, OpenDaylight plays a big role, and also other technologies as well. Some of the other aspects of virtualized CPE gets into lifecycle management. That's another fundamental requirement, which is the ability to deal and automate the overall lifecycle of those services, of those virtualized functions that are going to comprise that network service. And then to be able to integrate into the back-end environment, not even the back-end, but integrate into the broader architecture framework that actually is guiding the development of virtualized CPE and deployment for that matter. So if we look at the value proposition virtualized CPE, it should be pretty clear by now. I mean, we talked about it already. A lot of it is to be able to address that problem statement, to improve agility and time to value. Time to value is an interesting metric that some of the network equipment manufacturers who we work with and are also supporting or thinking about, which is not just time to new services, it's time to revenues, it's time to achieve cost reductions, it's time to actually get derive the benefit, not just be able to take that step and do something a little faster. In addition, it's about reducing OpEx cost through automation. And this one has been discussed throughout the day, throughout the year, actually throughout the last 2 years. So I don't need to say much more about that. And then it's also about reducing CapEx cost, not just through commoditization, that's one aspect of it, but it's also through improved and optimized utilization, which is what the intelligence in an automated and NFV and SDN infrastructure provides, but it's through simplification, and this has implications on the people side as well. And just to share some additional market research, this is another survey that Infinetics had provided, since they've done a lot of work looking at virtualized CPE and also virtualized services delivery, SDN-enabled NFV. And this is a chart, it's a little bit of an eye chart. The question was, what are some of the top use cases and when do we expect to see them? And if we look at this chart, which is about a year old, business virtualized CPE is at the top of the list. And then virtual service chaining is next. IMS core for the telecommunications infrastructure is next. And then if you go down the list, it's virtualizing a lot of the capabilities within the telecommunication operators network. This survey had a smaller survey size, about 29 operators, excuse me. But it is indicative of what's really happening when we talk to some of the operators who are driving some of the largest networks in the world. They clearly are interested in virtualized CPE, and they want to be able to capitalize on that because it provides that triple play value proposition of improved agility and at the same time reduced costs, both OpEx and CapEx. So from our perspective, what are some of the key use cases that are driving virtualized CPE? Well, first of all, one of the key ones is to enhance basic services. The idea here is that if we look at the competitive landscape, we look at margins being eroded because of increases in spending, increases in capacity, not to mention flattening revenues. Now we have to provide a means of helping operators cope by differentiating basic connectivity services that affect all of their subscribers. For instance, if you think about residential broadband as an example, and one of the things that operators can do is try to compete on a commodity level within their service areas, and there's probably going to be some limited competition. But another thing they can do is enhance some of those basic connectivity services, like to residential consumers, by providing an additional value-added service capability if it's efficient enough across that subscriber base. And if they can do that, now they have a differentiated offering that doesn't add excessive amount to the overall cost of delivering those basic services. Another use case that we've been addressing is to enable new business models. And this has to do with the commercial side of the service offering. Our operators are now beginning to, and have been for the last couple of years, beginning to offer subscription-based services. It used to be, if you wanted to offer managed services, there was a certain contractual model where there were upfront costs, there were investments in the infrastructure, the appliances that are providing those capabilities, so all the participants in that value chain and in that collection of providers are delivering. And then, of course, there are slightly different models that various different system integrators used, or even telecommunication operators are used to deliver that value to individual, or in this case, business customers. The idea now is that if we have the ability to offer more granular services that can be scaled out across a broader infrastructure and a broader set of subscribers, now we have the potential to allow things like try and buy, short-term services, dynamic services, all these different types of models that have very different commercial implications. They don't get priced the same way. They don't even get assured the same way. I mean, it's a different kind of business model. And it's because of the fact that we can automate to be able to enable those services. And then finally, we want to also be able to provide the new managed services, or in other words, more sophisticated capabilities that not necessarily all of the customers or subscribers are interested in, but certainly a subset of them are, and then be able to help efficiently enable those operators to deliver those new capabilities. So an example would be a more highly secure service, or encryption, or WAN optimization. It tends to come up. It's one that it has to be necessarily deployed, or typically is deployed at the customer side. So these target use cases are how we sort of define and characterize virtualized CPE. Some of the additional requirements, well, it wouldn't be SDN or NFV if we didn't start with openness. Now, what is openness in the context of virtualized CPE? Open source is a part of it, no question, but openness from virtualized CPE is the ability to support a diverse set of virtualized network functions, VNFs. Again, if you're familiar with the NFV and the NFV architectural framework, you know what that means. If not, these are the virtualized capabilities that are going to be strung together or chained together to be able to offer a service in the network. Efficient personalization, or an ability to be able to customize those services. Operators are not going to be able to differentiate if all customers are treated the same. And they certainly are going to have to incur additional cost if that was the case, because either you sink into the lowest common denominator, or you're actually delivering more value to some customers than they're willing to pay for. So you want to be able to take advantage of the fact that you have some level of personalization and customization to get to the point where you can deliver subsets of customers and segment those customers and deliver each what they really need and what they're willing to pay for. Automated virtualized network function lifecycle, it's what we've been talking about throughout this, even from the beginning. The idea is that we are able to automate to deliver operational cost savings, and at the same time to speed up the introduction of those new services. Application level service chaining. This is an idea that we don't necessarily have to look at providing virtualized network functions and look at it as a one-to-one mapping between VNFs and virtual machines, or even containers. What if we're able to actually integrate multiple different virtualized network functions into a single VM or container, and then be able to chain those together? That's application level service chaining. And that is the way in which we can enable the customization that I was mentioning a bit earlier. And then being able to provide flexible deployment. Clearly, we need to provide most of the virtualized network functions at the provider side, whether it's a CO, whether it's at the CMTS. And then we want to provide some at the customer side as well. Things like security typically come to mind, or monitoring. The ability to scale out versus scaling up. Scaling out means that we're going to be able to take those services and address millions of service endpoints, versus scaling up, which is to create large, huge amounts of capability per implementation, but for a limited set of customers or groups of customers. And then, of course, like we mentioned earlier, the ease of integration with the back end. And this has to do with the OSSs, the basic support, the business support systems that are actually the key to being able to deliver services or not. Because if we can't bill for services, if we can't order services, that determines more of the revenue flow than anything on the technology side. So ClearPath has actually developed a virtualized services platform, which is our virtualized CPE offering, that enables very efficient delivery of managed services that have some of the properties and the requirements that we've been talking about. I mean, so if we look at the bottom is the customer side, and at the top is more the provider side. The idea is to be able to offer a container that has a very flexible and compact footprint that allows for a number of different relatively small VNFs that can be application chained together to offer services that can be scaled out across a large subscriber base. And that subscriber base can be grouped together, so we can offer more of a group-based approach, or it can even be down to the individual customer or even below that. Of course, there's going to be implementation and performance implications depending on what the numbers are. If we're talking about a million, 10 million, or 100 million, certainly there's other implications. But the idea is that if we can provide a very compact container that's maybe on the orders of tens of megabytes, not hundreds of megabytes, which is more typical for virtual machines, then we're able to actually change the economics, which is the premise that we have in offering a platform that can deliver virtualized CPE to the kinds of customers that we've been talking about, which typically large operators who are offering services to a large number of their customers. So one of the aspects, and this talk is really about software-defined networking, and before I get into how virtualized CPE is evolving, I want to talk just for a minute on software-defined networking, because even though we're 4 or 5 years into SDN or more for some of you, and maybe a little less for others, I just want to make sure that we're clear on what we mean by that. And I'm going to actually borrow from the Open Networking Foundation definition of software-defined networking, which is a network that provides logically centralized control, it's programmable, and it's abstracted, and it's open. So let's take each one of those. Logically centralized control. That does not mean a separation of the control and data plane. That was the definition that got SDN off the ground, but it's evolved since that time. There's no question we're going to see control capabilities embedded into the networking devices near the forwarding. It's just not, it's bound to happen. In the telecommunications world, it's required. It's just, you can't provide the resiliency. You can't provide necessarily the monitoring and other capabilities with a completely centralized system. Logically centralized control also means that we're going to need to create a physically distributed means of implementing this SDN controller that's providing that logically centralized control. Well, this isn't a new concept. This is how we deliver network management today on a broad scale in telecommunications and cable networks today. If we look at programmability, what does that really mean? Well, programmability means that we have this ability to change the network behavior through some application programming interface. And there's been a lot of work within the Open Networking Foundation, OpenDaylight, other controller framework projects like ONOS and others to be able to address this very point. Not to mention Cisco's work with group-based policy, other manufacturers who are also getting involved in this. This is a really hot area, and it's a big area because what we want to do is ultimately be able to leverage the intent that's been discussed throughout this conference and then be able to provide a portable way of taking the network intelligence and being able to port that to different controllers. And then finally, abstraction. Abstraction is this idea that we're able to leverage a common set of control intelligence across diverse types of networks, diverse types of devices, and diverse types of technologies. So for instance, if we want to be able to add a layer 1 OTN switch at the bowels of a carrier network, or a router, we should be able to do that without necessarily changing some of the fundamental control that's provided on top of that, which is, for instance, how services are placed, how protection bandwidth is managed, and so forth. So when we talk about software-defined networking in the ONF, that's really the context of what we mean. It's more this idea of the programmable network, an open network, and then, of course, a network that provides for a blended or hybrid control model where we're exploiting intelligence in the network that's logically centralized, where it makes sense, such as being able to look across the network and determine the best paths to choose, but at the same time also relying upon embedded functionality where it makes sense, like monitoring 200 gigabit channels on a transport network as an example. So with that as a backdrop, I want to talk about virtualized CPE evolution. Well, we started with physical appliances. This was the backdrop behind network functions virtualization. And again, for those of you who aren't aware, over at the San Jose Convention Center, the ETSI NFV Industry Specification Group is meeting right now. This is the group that created the NFV architectural framework that's sort of guiding not only virtualized services, but even what we're doing with virtualized CPE. They started with physical appliances. Then the first phase was to virtualize what the physical, just to take the physical appliance and virtualize it. And if you're a manufacturer of one of these physical appliances, this makes a lot of sense. You're going to be able to leverage all your investments. It's relatively straightforward to do. And many of your customers who have actually invested in the management of these physical appliances are going to understand how that would work. However, that's really not the end goal. Really what we want to do is to exploit the NFV architecture. And then we're able to do things like decompose those physical appliances into more granular virtualized functions, and then be able to deliver those into a more efficient environment, like not only what ClearPath offers with our VSP platform, but what others are offering as well. To be able to take virtualized network functions and at a component level, and then be able to at an application layer, service chain them so that you can actually embed those into a single container at a fraction of the resources and cost that you could do with virtual machine. The traditional model of I'm going to virtualize the physical appliance, I'm going to put it into a virtual machine that's relatively large, and then service chain them over the network, which is traditionally how service chaining has been done. And then finally, we want to exploit SDN. And we're going to talk in more detail how we're going to do that. But the idea is to be able to virtualize now across multiple containers that include multiple service chains, and then be able to take advantage of the dynamic and programmable aspects that SDN is providing, and that, again, we've been talking about all week. So I want to go into a little more detail of some of the individual aspects of virtualized CPE and how it's evolving. First, what are we virtualizing in these different phases? Well, in the first phase, we were virtualizing the physical appliances. I mean, it's pretty obvious. The second phase, we're virtualizing virtualized network functions. So we're actually simply taking the appliance, decomposing it into some level of virtualized network functions that actually have some reasonable boundary and reasonable value that they're able to offer, and then be able to develop those. And then when we get into software-defined networking, if we had the ability to bring together containers or VMs even that can be service chained at a higher level, then we're able to even decompose those virtualized network functions into libraries that can actually be delivered even more compactly. And this is how we achieve a scale-out system over the long term. Types of virtualized network functions. Well, we didn't have one with physical appliances. And then we start to move into NFV. The first types of virtualized network functions and virtual appliances that were addressed were infrastructure, meaning the carrier is looking at the appliances they're actually running their network. But over time, we're going to see more customer-facing VNFs. And these are going to be smaller inherently because they're going to be personalized. They're going to be customized by creating these decomposed virtualized network functions, and then being able to flexibly chain them and deploy them where they're needed. Service chaining level, we used to hardwire physical appliances and even some of the first level of virtualized appliances because we didn't have software-defined networking. At the NFV level, there was a understanding that we were actually going to go to the next level, which is a network level service chaining, and then ultimately we want to get to the application level network service chaining, which is what we're providing by offering multiple virtual network functions into a container. Scalability target. Well, originally we had to worry about hardware. Just if we had a larger virtual appliance or physical appliance and we had to provide additional capacity, it was all about hardware. NFV was originally addressing infrastructure level and virtualized network functions. It was really more about scaling up. It was about the fact that carriers have huge networks, cable operators have even very large networks, and they need to be able to provide functions like firewalls, load balancing on a huge scale to be able to address all the needs that they have internally in delivering those services over the internal infrastructure. And then ultimately, it's about scaling out. So again, scaling out is we don't necessarily need huge amounts of processing capability, but we need to be able to manage it across millions of subscribers, as we mentioned before. So the ultimate goal is to be able to virtualize at the first level, cloudify, which is the next step, which is what NFV set the industry on the path, which is to exploit the cloud and re-architect the virtualized application, or excuse me, appliance, so that it can start to take advantage of aspects of the cloud. And then ultimately, we want to be able to optimize using software-defined networking. So the idea really is that to continue the evolutionary path that we've already been on, that virtualization is accelerating and software-defined networking is going to accelerate even further. Virtualized network function is no longer a theory, it's in practice. Some of the world's largest operators have been able to demonstrate that and trial virtualized CPE, and there is a lot of interest. For instance, at Telefonica, that project has got a lot of attention. The trials they were running in Brazil. Colt has been a very solid advocate. They're a pan-European carrier, if you're not familiar with Colt, about virtualized CPE, and some of the Colt technologists have been really upfront about sharing their experiences. I mean, I've seen a couple of really interesting case studies that Colt has in their investigations. My company was involved in AT&T and China Mobile and Dell in a virtualized CPE trial that we share. Actually, it was a proof of concept, not a trial, that we actually shared in May of this year. And then Cable Labs has actually instituted the Virtual Home Network project that I think there were some references made earlier. I think Phil McKinney in his talk, in his keynote earlier, alluded to the Virtual Home Networks project. Cable Labs also has a virtualized business CPE project as well. This is really happening on a broad scale, even though there's a lot of, we have a lot of work to do before we actually are providing mainstream virtualized CPE. So when we think about the SDN architecture and how SDN can enhance virtualized CPE, I just wanted to share a couple aspects that we're thinking about for the near future. And clearly, the traffic steering ability driven by an intelligent SDN control model and infrastructure is going to allow for very flexible deployment of service chains across a number of different configurations, across different domains, across certainly the important customer to provider boundary. And SDN is going to be it's going to be an invaluable resource to be able to do that. SDN is also going to be able to offer enhanced security and monitoring. SDN actually has the potential to really change the way network security works by up-leveling the discussion on how traffic can actually be routed or diverted, maybe. I don't want to use routed. We have enough ambiguous terminology. I don't want to misuse that term. And then even monitoring to allow operators unprecedented visibility and taking advantage of the advancements in analytics as well. Programmability is equated with differentiation. Now, operators have the ability to create the network behavior and drive the network behavior that they're looking for and drive the services that they're looking for, as opposed to relying on the vendors who have traditionally offered capabilities which, frankly, are available to any of the service providers who purchase that vendor's equipment. And that's been a very key driver behind software-defined networking. The other aspect of programmability is this concept over the long term of being able to exploit dynamic network services, temporary services, bandwidth on demand, but in a more dynamic and flexible way, and a range of other services that the ability to run third-party or even provider and network operator developed intelligence on top of this network infrastructure that's tailored to the individual environment or the individual domains. And then finally, automation. And again, automation gets a lot of attention in the SDN and NFV circles. It's very clear automation is going to drive down OpEx. It's going to drive down manual errors. And it's also going to simplify the management of the infrastructure. And automation in many of the architects' minds and some of the large operators is to make the network more like servers. And I think that analogy is appropriate here as well. So we see virtualized CPE as an opportunity that's going to unfold quite a bit over the next probably 2 to 3 years. We will see a lot of trials. We're going to see a lot of activity. We're going to see a lot of interesting plays as orchestration meets SSDN controllers, meets virtualized CPE platforms, and it's also going to provide for even lower layer functionality that's going to emerge in OpenDaylight and other controller technologies as well. So, so with that, I wanted to make sure we allowed some time for questions. So I'd like to open up the floor. I think we have a few minutes, 6 or 5 minutes or so, or 7 minutes. So any questions on virtualized CPE? Yes?
So what kind of devices are you actually deploying your virtual CPE? So there's got to be some piece of hardware that's running this, like in somebody's home that you picture. There's either a cable modem, a VHR, or something inside the home. So how are you getting your virtual CPE on that device?
Well, clearly we're not providing a hardware solution. We're providing a software solution that needs to be wrapped into, and it has to support a pretty flexible deployment environment. We're not trying, we have worked hard to maintain independence from the individual hardware platform and decouple that so that we don't run into some of the traps of being too tightly coupled with any particular hardware solution. But the reality is that we're probably going to have to, I mean, again, on the CPE side, the customer side, we're going to have to work with operators. We're going to have to work with some of our partners who we are going to provide a broader solution to be able to integrate closer in their hardware.
So is it one of the prerequisites to be running an x86 platform for this to be?
Well, we're running when I say I can talk a little more about ClearPath here, but the industry as well. We're looking at more of a Linux container. Well, it's a container model that's running on a Linux, and it can be adapted, but we have to look. The answer is always when we get into hardware is it depends. So we have to look at the individual environment. So other questions? Yes.
I want to know that what the scenario about this VCP that's run that just in the data center or also can run in the branch, for example, the carrier's web area to the branch, or only in the data center.
I'm sorry. The question was, you want to know about?
What's the scenario that this VCP just can deploy mainly in data center or just also can be for the carrier branch?
Well, virtualized CPE in the generic topic, I wouldn't constrain it very much. What the use cases that ClearPath my company's been interested in are really more in these scale-out applications. They have to do with being able to deliver services to small and medium businesses, to residential customers, to also distributed enterprise, but really more in the smaller level. They're scale-out applications. So it's not really intended to provide big network appliances that are in VMs and then service chain those VMs using SFC and other network-oriented service chaining methods. It's to be able to provide a very compact, containerized, and personalized means of being able to offer services and then being able to deploy those services in a flexible way that could be scaled out over millions of service endpoints. Yes?
Are you building the VNF applications or is the customer building
Well, actually, it's not so much our customer. We want to partner. ClearPath is a relatively small entity, so we don't expect to be building a huge ecosystem like some of the other vendors who are participating in the network function virtualization space. So we've been working with open source capabilities because of the cost implications and the accessibility to us. But we have no dependencies on open source, and we'd be working with commercial vendors as well. And we think that the actual model, the realistic commercial model, is that the network operators who want to deploy this platform are going to have very strong opinions on the virtualized network functions and the capabilities that they want to deploy to deliver these services. And we're going to work with the partners that they expect us to work with. And then we're going to forge our own relationships and arrangements to be able to do that.
Okay, if you don't mind, I want to ask a couple of follow-up questions. How many VNFs do you have in mind? And does the network operator really care whether you're running them in a container or as long as they're able to scale your application that's already much?
Well, it's not just the scale. Scale is a multi-dimensional issue here. The operator may not be so concerned about the individual technology that we choose. It's not about, it has to be Docker, it has to be VM, it has to be LXC. That's not what we're really talking about. What we're talking about is how do you alter the economics? How do you get the cost down significantly lower to where it is today so that you can scale out in a cost-efficient way to be able to address those use cases we were talking about, like enhancing basic services where that service is going to be delivered across a wide range of subscribers. It's about how do you take cost out of every aspect of that delivery of that service. That's what they do care about. That's what's going to be the determining factor of whether it's even viable to create a enhanced basic service versus a service uplift that's going to apply only to a small number of customers, which again, very valid use case, but it's a different use case. We can certainly address it, but that's not the focus of what we're thinking about. It's really more about these scale-out use cases. And as far as the number of VNFs, it's not really limited in terms of what limits them is we have to onboard them. We have to integrate them within our environment. And we have built some tools and built a methodology to facilitate that, to actually reduce the amount of time and effort to do that, because there is going to be, it's not seamless. We have to be able to manage we have to address the entire life cycle, and that's going to take a little effort. What we're working towards is to shorten that time, again, to be able to onboard VNFs, new VNFs, much more rapidly, and then be able to manage them more efficiently. For instance, we don't want to see a model where there's 100 VNFs or 1,000 VNFs, and we have one EMS for each one of those. Or worse, a physical and a virtual. I mean, that is just untenable. So what we want to do is to be able to provide a more integrated solution by providing the hooks to be able to offer an efficient implementation of virtualized networks, or virtualized CPE, across a diverse range of VNFs for a diverse range of customer applications and environments. But great question, because that's at the heart of the whole discussion on virtualized CPE. So I think we have time for one more. I think we have seconds left, or if not, I want to thank you for the opportunity to participate, and thank you from the board's perspective, thank you for participating in OpenDaylight. Neela said it many times. It's about the community, and OpenDaylight has the most amazing community in anywhere, really. And I'm participating in a lot of activities myself, so thank you.